divisibility statement is a method to prove divisibility such as divisible by 2, 3, 4, 5, and etc. Same as mathematical induction fundamental hypothesis. Assumption is also made at the step 2.
N cubed minus n plus 3 is divisible by 3 for every non-negative integer. For step number 1, let n be equal to 1. Substitute 1 to all n in the equation and the answer will be like this. N equals 1 is true. For step number 2, let n be equal to k. Substitute k to all n in the equation and then, assume that all the positive integers is divisible by 3. So the answer will be like this. And then for step number 3, let n be equal to k plus 1. Substitute k plus 1 to all n. We know that k cubed minus k plus 3 is equal to 3x, so we substitute 3x to k cubed minus k plus 3. Factor the expression. Since we factor 3 from 3x plus 3k squared plus 3k, we conclude that the statement n cubed minus n plus 3 is divisible by 3 is true for every non-negative integer.
N squared plus n is divisible by 2 for all positive integers. Step 1. Prove that n is equals to 1. So substitute the 1 to the n squared. 1 squared plus 1 is equals to 2.
Step 2. Substitute all the value of n with k. Step 3. Use the value n is equal to k plus 1. So it's going to be quantity k plus 1 squared plus k plus 1. Substitute k squared plus k with 2x. Factor the expression. From there, we can conclude the statement n squared plus n is divisible by 2 is true for all positive integers.
Number 3. Prove that 11 raised to n minus 6 is divisible by 5. Step number 1. Use the value n is equal to 1 and substitute it to the expression. The answer is 5. Therefore, n equals to 1 is true. Step number 2. Let n be k. 11 raised to k minus 6 is equal to 5x. We use 5x since it should be divisible by 5. Step number 3. Let n be k plus 1. 11 raised to k plus 1 minus 6. Remove the plus 1 in the exponent by multiplying it by 11 raised to k. Expand the 10. Multiply 10 by 11 raised to k and 1 by 11 raised to k. Bring down negative 6. 11 raised to k minus 6 is equal to 5x. Substitute it. Factor 5 from the expression. Step number 4. Therefore, the statement 11 raised to n minus 6 is divisible by 5 is true. Proving inequality statements is a method to prove that mathematical induction inequality is being used for proving inequalities. It is quite often applied for the subtraction and or greatness using the assumption of the step 2.
Prove that 4 raised to n minus 1 for n is greater than or equal to 3. Step 1. Use the value n equals 3. Substitute it in the equation. The answer is 16 is greater than 9, which conclude that n equals 3 is true. Step 2. Use the value n equals k. The equation will be 4 raised to k minus 1 is greater than k squared. Step 3. Use the value n equals to k plus 1 and substitute it to the equation. 4 raised to k plus 1 minus 1 is greater than k plus 1 quantity squared. 4 raised to k plus 1 minus 1 is equal to 4k. From the step 2, times the equation 4 raised to k minus 1 is greater than k squared to 4. It's going to be 4 raised to k greater than 4k squared. Since we knew that 4 raised to k greater than 4k squared is true, we need to prove that the quantity k plus 1 squared is less than 4k or 4k squared. In the case of we use 4k squared. Expand the quantity k plus 1 squared. Transpose the combined like terms, then factor. We try to substitute 3 to the factor equation to prove that k greater than or equal 3 is true. Therefore, the statement 4 raised to h minus 1 greater than n squared for n is greater than or equal 3 is true.
Prove that n raised to 2 is less than 2 raised to n, for n should be greater than or equal to 5. Step 1. Use the value n is equal to 5. Substitute it and the answer will be 25 is less than 32, which means n is equal to 5 is true. Step 2. Use the value n is equal to k. Substitute all the n in the equation with k. And it's going to be k squared is less than 2 raised to k. Step 3. Use the value n is equal to k plus 1. All the n should be replaced with k plus 1. So it's going to be quantity k plus 1 squared is less than 2 raised to k plus 1. Use the equation k squared is less than 2k from the step 2 and multiply it by 2. Since we knew that 2k squared is less than 4k is true, we're going to get the k plus 1 quantity squared from the first equation in step number 3. To prove that quantity k plus 1 squared is less than 2k squared, we should expand the k plus 1 squared. Transpose the k squared plus 2k plus 1, then combine like terms. We will transform the negative 1 into 1 minus 2, so that we can use the k squared minus 2k plus 1 as quantity k minus 1 squared, then bring down the negative 2. To prove that k is greater than or equal to 5, we substitute k with 5. The answer will be 0 is less than to 14. From there, we can conclude that the statement n squared is less than 2 raised to n for n should be greater than or equal to 5 is true.